welcome back to Chakde System Design series. In this episode, we are going to talk about something very core to my heart, which is optimization technique in JavaScript. We will be talking about popular memory leaks in JavaScript and how to basically fix those. In the previous episode, we have talked about the network optimization and asset optimization. And trust me, this is going to be way beyond that. Okay, so who's this episode for, right? If you are a fresher who think you don't have enough thing to work like learn in JavaScript, or you are a senior who thinks, yeah, like you are a pro in JavaScript and you have done whatever you can do in JavaScript, right? Or you are a person who thinks about if you have to optimize certain things, especially the memory space optimization, DSA is the only way. So trust me, I bet so you will change your perspective till the end of this episode. So keep watching this episode because we are going to talk about so many popular memory leaks which you don't know. Basically, when you are writing the code and accidentally you do a lot of mistake while handling DOM, when you are working with closure, when you are working with a global variables, when you are working with timer listeners, event listeners, cycle, you are writing some cyclic loops, you are handling promises, you are handling observers or observables. All of these things, when you are making a lot of accidental mistakes. So trust me, so it is going to be very nice journey till the end of this episode. So keep watching this episode till the end. Let's talk about our first memory leak that we do very often, and unintentional, right? And let's see. So I hope you understand global variables. So what we are going to discuss first, accidental global variables and what it meant. So in order to understand it better, let's understand few fundamental terminology, and then we will ramp up on something. Okay, so there is something called window object, right? When you go over this, you see this is an object which can be accessed from anywhere in your application. That's why that is called a global object or a global reference. Okay, now what we have to do, we are going to say, suppose add a variable and going to assign a value to this, right? And if I go in and check for window dot a, what we have done, we have assigned a value of a is equal to 10. Now we are checking if that variable is available on window object, which is a global variable for us, right? Yes, that is available. Okay, so similarly in our code base also, we keep on doing this thing very often. Like we are trying to assign a variable which is having some value, say suppose 15, and basically what we do, if I go and check on the window object, basically it got reloaded. Let's see if that is available or not. Yes, that is available. So what is another mistake it can happen? Obviously one is memory leak, second is anyone can overwrite this value as well. So what it meant by, if I go and change it to 25, and if I try to access value of b, you see accidentally anyone can like change your value as well. Okay, so coming back, this is one of the way. Okay, probably you are smart enough and you might not be doing this, but let's take another example. You are defining a function, and that function is maybe abc, some function is there, and you are trying to assign a value into this. Maybe your value is some variable, or in order to avoid the confusion, maybe we have some c is equal to some statement, I check the system design. Okay, this is something, a statement which we have written. Now what we are going to do, basically call this function which is abc function, and I'm going to basically do a console.log. What I'm going to do, console.log, let me check if this variable is available on window object or not. Let's see. Oh, it is available. We can see hi Chakde System Design got printed. Basically this variable was basically assigned a value inside this function which is abc. Then how come this variable is basically available on the window object? So for that we have to understand, like if anything which is not declared inside a function, it actually get initialized or declared basically at its parent. And in this case, what is the parent from where it is being called is a global reference or a global space, we are basically calling it out, right? In this case, that's why. So again, there is another kind of mistake generally we do. What are those mistakes? Say suppose instead of calling this abc, there is a function called abcd, and in this case there is a variable called d, and check the system design, and probably I'm calling this abcd again. In this case, instead of basically assigning this value to directly to c, maybe I'm assigning this to this dot d, and over here I'm calling this function again and trying to access this d. What do you think? What will be the output? Will you get the value of D as in love to check the system design, or you won't get? It will be undefined. So let's try it out. You got this. Why? How? We have to understand. Like again, as this is a named function, this is not an arrow function. In arrow function, the way basically this is defined, or this is referenced to, is completely different as compared to the named function. So this is a named function, so you can go into the detail, you can understand. But again, these are some accidental thing that we do in terms of we are accidentally leaking some value, some references to the global space where anyone can access. Definitely that is a memory leak, and on top of it anyone can override as well, right? What we should do in such cases basically, is there any better way where when we are coding basically we can get to know, oh, accidentally we are trying to populate or consume a global variable or write to a global space? You can do just simple thing, which is use strict at the top of the file, and you will see B is something which is not defined, so you can't basically accidentally leak it to the global variable. Okay, let me fix it. C is not defined, which is says that C is not defined, and basically you have to declare this value. Maybe I could have declared like this, right? Let's see what it says. It says that for C you have to declare it. Okay, and now it says that D is also not declared. Probably there is a better way. If you basically create a new instance of this, you can do better than this, right? Or you are not using this, you are using some arrow functions. There are better ways to basically achieve this, right? So using a simple thing which is use strict, you can see you can avoid a accidental global variable leak that you may be doing. So let's see what's the next one. Let's talk about the second memory leak. So this is maybe like most of the people may be aware of, which is a timer. Like you use set interval in JavaScript, right? Or you have certain callbacks which uses some references. So in our case, what we are going to do, so consider we are having a DOM element. In our case, there is an ID called node and there is some text which is written. The intent of this adding a set interval is basically what we are going to do. We wanted to change this node value if it is present in the DOM. So in your case, it can be some data which is asynchronously loaded, or some DOM references which are getting added from somewhere and you don't know probably, right? Sometimes you wanted to add some interval in order to achieve or do some operation on top of it. In our case, we will be doing something similar to that. So what we have done, just for the sake of example, we have added we are checking if there is a node ID which is present. Yes, then we wanted to change its value with something new. In our case, what is this something new? There is a JSON, we are trying to do some stringify. Just wanted to highlight some complex operation. That's why I have added a stringify over here, which is doing a stringify from the reference that we got, or object basically that we are getting from this function. So in this particular case, I am saving it. Now let's see. We got our data updated, which is name Chiragwell got printed over here. But do you see a problem over here? There is a problem. Your node or your DOM tree is getting re-rendered again and again and again. Why that is happening? Because we did a mistake. Our intent was complete, but still we are basically trying to keep on updating this. So the problem is on the UI, you won't see anything is changing. Your intent is complete, but behind the scene, there is a leak which is happening. Your computer is trying to do some extra job, and which is causing the performance dent, right? And if a big application, you will be able to see this very easily. What we could have done this, we have cleared this out. How we can do that? We can we can reference the set timer, set interval basically in terms of a variable which is timer over here. And once our intent is done, we could have called clear interval and pass that reference over here, which is a timer in our case. Let's see what has happened. Again, the value got updated, but you see it is not re-rendering the DOM tree again and again and again. So it improves the performance, it reduces the memory leak, accidental memory leak. Wherever you are using the set interval, try to be sure once your intent is done, are you clearing that up, which is very, very important. So let's check out the third memory leak. Let's talk about a third memory leak. So which is very obvious, like we keep on adding this event listener, and sometimes we add it using JavaScript, and sometimes behind the scene we use it in React or somewhere, right? Let's understand what impact or dent basically we can cause if we don't remove this listener. Let's quickly see. In our case, what we are having, are having two things. One is a button and second is a text. On click of this button, I wanted to update this text. As simple as this is nothing special over here. But In this case, on the left hand side, we can see that we have a event listener. On click of this, it will just console are clicked and it will replace the text with the text. Fair enough. Now, in order to mimic the problem that you can actually cause when you are repeatedly adding this event listener, or probably are using inside a React hook, maybe use effect sort of thing, right? I'm going to add a re-render method. Re-render is just going to call this add listener on a certain interval, which is say suppose 500 ms. Let's see what will happen. If I click for the first time, my job, which was to update the text, is done. Even if I click multiple times, nothing wrong is happening in terms of the UI. Not a problem. But something else is messed up. Can you see that? Let's focus. I'm going to click it on the third time only on the click me. But you see how many time it is showing the console.log? 65 time. Dude, how come? Like I just like clicked the third time only. Let's go and see the problem. When we go into the elements, when you go into that particular item where you have added a listener, I clicked on this, go into the event listener. Let's focus how many times this listener has been added. If I go and try to reload, trust me, you will see like these occurrences are actually getting increased. There are so many number of occurrences. What the hell is happening, right? Definitely, as we are not removing this listener, these listeners are getting increased, and every time when we click, those are the number of occurrences. You see how many times the internally browser actually executed this. So that's a problem. Do you see the problem over here? Now, how to fix it? I know most of the people are smart over here. What you can do, one simple funda, which is move this particular function outside so that you can have a reference. On click probably, and okay, we were already having a function, no problem. You can have this over here now, and you can pass this reference over here. Similarly, you can create another function which is called maybe remove listener. We can name a function which is called remove listener and pass and create another method or execute another method which is called remove listener, event listener, right? We have to pass the same reference. Notice that is very, very important. Whenever you remove any of the listener, you have to use the same reference in the add event listener and the remove event listener. Now, what I'm going to do, every time I try to add, first I will remove the existing one and then try to add a new one. Although in the new browser, you will see things are bit smarter where you might not have to execute this. If you are passing a reference to a function, automatically try to clean up, but don't worry about that. In our case, let's see what is happening. I go click, my job is done, text got updated. Over here I see click got over here. I'm clicking the second time and the click is getting added as in second time only. Like third time I clicked, only the third click is basically being, you can see the console.log got executed third time only. It's not getting executed every interval because it is first removing the existing listener and then adding a new listener, which is very, very important. Now, sometime you can add these things, but sometimes why do you want it to take this overhead kind of thing, right? You may be having a simple use cases where you have a model. When someone click on cancel, you basically probably wanted to remove that dialog box. As simple as like no repeated job. I wanted to execute my job only one time. I don't want it to repeat my job multiple times. I don't want it to then take attention of first adding it, then removing it, and do then blah blah blah. So what can be done? You can just use a simple trick, which is when you are adding an event listener, just pass something called a third parameter, which is once true. That's all. Just to highlight, once true, third parameter. That's all you have to do. And if we go try to execute this method now, if I go and click on this, it got clicked, my job got done. Say suppose this was a model, I wanted to click on cancel, my cancel is done. Now if I try to click another time, dude, our listener has gone. So internally it will get rid of the memory space as well. So now you have to understand, when we were doing this repeated time, when we were having multiple listeners, if there are certain variables which are created, maybe some heavy variables are created over here having some like huge values, you can see how much dent it can cause. So it won't, your garbage collector won't clean up those spaces, those references basically. And there is a listener, but inside those callback you are also having those memory spaces which are consumed by the variables and the stores that you have utilized. So always when you are adding an event listener, do handle it with care and must try it out. Let's talk about fourth memory leak that generally happen with the DOM references. Okay, behind the scene, again, it is very difficult to visualize this, but if you have the fundamental clear, then it helps to basically clean up the memories which we accidentally leave it behind the scene, and it causes the dent. Okay, let's see the use case. In our case, we are having some reference which is, say, suppose I am creating a reference DOM or reference element. This is any element that we have. This is the element basically. We wanted to operate on this element. Maybe in JavaScript you wanted to access this, modify this. It can be your to-do list where you wanted to click on this, add it, remove whatever activity you wanted to do in this particular reference. Now, in console, in script, what I have written, I have just got this variable, I just stored this variable, and I am going to console.log this variable over here. Okay, I am doing console.log, and this variable is basically getting printed, which we can see. Now, the next intent which I'm going to do is I'm going to remove this child element. So I just got document.body like remove child, and I'm from the body I'm going to remove this element reference, which is body.get element by id, and this reference is something which I am deleting. Fair enough. So what will happen basically in this particular case, if I do console.log, let's see. We will see if I try to access this DOM element again using the ref1, nothing is getting printed, which is null, right? So DOM got deleted, which is for sure, which we can see from here. But when I try to access the console.log a, the variable where I have stored the previous value, do you see a problem over here? Okay, what is the problem? You still see the DOM element is present. How come? I removed this element. Next time I am trying to access this element is definitely not available. But somehow, because we stored into some variable, into some reference, that reference is still is pointing to that particular DOM. Now, consider if the DOM that we have tried to access is huge, is heavy. It has so many nested stuff, right? You can see what kind of dent it can cause. Okay, let's try to play around certain more things. Let's see what will happen. If I do something like, maybe I wanted to modify this reference altogether, I am making it null and trying to access these two things again, which is console.log. Maybe I can do one more thing to differentiate, which is if I do console.log and maybe I create a differentiator. Okay, so let's see what happened. First, definitely there's a reference. Second, we remove the reference. We try to access via the document directly. We were not able to get anything, but via the reference, which is A, we were seeing it. But what we did, we actually updated the reference, which is A is equal to null. And we also basically, in that particular case, we try to check if the DOM element is present and if a reference is present. Both of them was null. What if I could have done in a different form? Let's see if that helps or not. Instead of doing document.get element by id and passing that and removing, what if I pass a as in value over here? Will it make any difference? No, it doesn't make any difference. Basically, you see your reference is still there. So what you should do, always when you are playing this, make sure you are not playing in the global space, because if you have any of these references and you are not cleaning it manually, and you are doing this operation in a global space, then you are going to create a dent, right? You could probably have done this in some ify function or somewhere else, which could basically help you to get rid of automatically cleaning up the variables where you are maintaining your references, which is very, very important. Okay, so I hope you liked it. Go and must try and play around these references. You will find it more interesting. About the fifth memory leak, which is very close to my heart as well. So this is one of my favorite. So closure comes with a lot of power, and closure, if you don't understand closure, it will give you a lot of glitches in your code base as well. It's very tricky sometimes if you don't understand it well, and it also results into memory leak. So let's see one of the memory leak that you may be doing in your code base, but you never realized. So what we are going to do, on the left hand side, if we see, we have a variable which I have assigned basically, which is the thing, basically anything that I wanted to store over here. And there's a function basically which I wanted to call it repeatedly, so that I'm doing some job which is on a repeated mode, right? Maybe using interval in our case. So in this case, what we have an interval where we are doing a job. And what is that job? I'm overriding the thing with something very huge. This, why I'm using this object, because I wanted to create a new references always, right? Every time I replace thing method is called, basically this is something which will be created again and a new reference will be created. Also, if you see the long string, when I'm talking about, I'm talking about a large uh, data which is being generated every time this replace thing is basically created. Okay, what we are going to do, and some method references I've kept. So if you see, if you go into the memory, we will see, as this set interval method is being called again and again, this object is basically created again and again every second. Basically, you see sometimes the memory over here will keep on increasing and sometimes it will decrease because new references are created. A garbage collector will basically come into the picture because the old method got removed altogether. So every time if we see replace thing, and old method is getting replaced and it is getting cleaned up, so the old references are getting overridden. Sounds fair? What glitch we can do over here? Maybe I'm just enhancing this code and I just wrote some line of code over here, and see the dent which we can cause. What I did, I created another variable where I'm storing this. I'm referencing the thing variable inside this because I thought I'm going to use this new variable which is original thing in another function, and that function I haven't used anywhere. Like in this replace thing, I am not using this function. What I'm just doing, I'm just referencing or consuming, trying to consume that reference which I created internally over here like this. I'm not using this method altogether. This is just an unused variable which we can see. Now what I'm going to do, let's try to save and see what kind of dent it can cause. On the right hand side, we will see the memory is like 22 MB. Now it went to 30 MB, 38, 46. It's getting increased like every time. What wrong is happening over here? Let's try to see and figure it out. The thing which we are doing over here is causing a lot of dent. We have referenced a variable which is created over here, which is not getting garbage collector because it assumed there is a method which was created and the reference inside that method maybe still used. No one knows, the garbage collector don't know. That's why this variable which we basically tried to use inside an unused method is causing a huge dent which we can see over here. Now the memory consumption over here is more than 200 MB, and if we leave the system like this, probably it can crash, and sometime you might have seen on your screen out of memory, right? So handle closure with very cautious, and very caution you have to put when you are using this closure. It's not just okay, I can create any variable, use those variable reference anywhere. It is just an unused method. How it can cause a dent, right? Anytime you or your senior or anyone, your colleague says that no, it can't create a dent, please refer to this video and give a snapshot how much dent this can cause. And always go and check your memory tab if you are doing something, playing with something memory, and you feel there is a memory glitch which because of your code. Go and try this out. Let's talk about sixth memory leak. So by references, in the previous we have seen you created a closure basically, and that closure can cause a lot of dent. In case of references also, you have to understand your references can cause a lot of dent. In this particular case, if we see, we have a x is an object which contain a internally, that is also an object that contains b. What we are going to do, we are going to simply do a small operation where I can see where y is equal to z. I'm just giving, you have to understand, like the objects are passed by reference, or like how the primitive and non-primitive data structures basically, or data types basically uh, share the data, and either that is by reference or the value. You have to understand. If you don't, then go and look into that. Okay, now what we did, we basically set it as a reference. Now y has a reference to x over here. In this particular case, what I'm going to do, I'm going to do a small operation, which is, let's go and test out what we have in x and what we have in y. We have the same value. Like if you see, go and check it out, you have the same value in x and y. So what I'm going to do, another operation, which is, maybe I can do a small console.log and create a separator so that you can understand well. I'm going to do small operation, which is, I'm going to mark my x is equal to maybe null, or I can keep it 1, whatever it is, right? I just mark it as 1. Let's see what value do we have. we have value of x is 1, but value of y is still that object. Although the y we created from x only, but still it has the original object reference, and you can see the object or original object is available over here. Next, what we can do, probably let's make tweak it more. I can do var, I can create another variable which is z, and I am going to reference a dot y dot a over here. In this case, if you see what we are talking about, this object. Now z is referencing to this particular object. Let's try to print all three values, which is x, y, z over here. Okay, we see you have x, you have y, which is a, and inside a you have a b, and this is z where your b is equivalent to 2 over here. Now if we do some operation on top of it, what is that operation? Maybe this time I wanted to say our y is equal to maybe 2. I'm just resetting the value of y. Let's see what will happen to our x, y, z. We see x got replaced, y got replaced, but our z basically still has the reference to this object which was internal to x. Basically you see the reference, and your memory is still not free, right? Your reference is still there somewhere inside your code base, inside your browser basically. Now let's try to tweak a small thing. Now in the final stage, what I'm going to do, if I clean up this value as well, make it null, let's see what we'll have as an xyz over here. Or maybe I can keep it 3 to make it simple. You see now xyz are completely vanished, you don't have any references, and now garbage collector can basically clean up this particular object altogether, its next nested references. So always when you are playing with nested objects, when you are playing with the references, assigning a reference to some other values, and you are trying to operate, you have to always think about, am I leaving a dent somewhere, am I leaving a memory glitch somewhere, is everything being cleaned up or not? That you have to basically take care of. I hope you are going to implement and use this strategy when you are basically working in your application. Seventh, memory leak. So detached window. In this particular use case, what we are happening, you might have encountered multiple use cases where you wanted to click on some button, you wanted to open some window, probably you wanted to keep that window open, and maybe after user has done some activity, either you close from the window or from the parent window you close it, or you wanted to make some actions from the parent window to child window, right? Those are certain use cases we keep on doing, right? Now in this use case, we are doing exactly same. I have a button basically which has the open notes, it has change title, I can close that particular note tab which I'm going to open. From the use case, we can see from the code basically we have 3 buttons, I have 3 IDs. What I'm going to do, there are 3 methods basically. One is to show the notes, second is to actually, when I click on this change title, it will keep on changing the title of the new window which will open, and finally it's a close notes basically method which I'm going to call, and it's just plain simple JavaScript which is written in order to tackle these scenarios, right? Okay, let's see what we are going to do. Before starting, I will go and check the memory basically what we have right now. It's like the JS heap size memory, this method is kind of deprecated. Also there's another alternative, you can try it out, or you can go into this memory tab and you can basically see how much memory basically it is being consumed. Now if I click on this open node, a new window is basically created over here, and you see the memory got bumped up over here. Similarly, if you see, the memory will bumped up over here. If I do certain operations, you will see the slide values are getting changed. I can click over here, the title basically got changed over here. If I see the value is bumped up from the previous one, and if you see over here, it's bumped up from the previous where we started. Okay, now I'm going to close the notes tab basically which we created, and let's see the memory size. Memory size is still almost the same basically what was the previous when we started with, when we opened. So memory didn't got cleaned up as much. If you see, it's didn't got cleaned up as much what we were expecting. Okay, so what we should do basically, what went wrong over here, actually we closed the window, but the reference of that particular window we didn't remove. So explicitly removing that is sometimes very beneficial, where you can specify this window reference, which is notes window which we created, is something which is set to null. In this particular case, if you try to see, like if I go and try to the same solution, first I will check the memory size. Probably this is like where we are starting something like 2.6, it's kind of like 2.4 this time, and a bit high. Let me click on nodes, try to click on some change title, and maybe this time let's see the what is the size which is getting bumped up. Okay, we started maybe from the higher one. It was taking a time to boot up. We see this is a memory basically which is being consumed over here, right? Which is right now 2.9 MB. If you see, we started from somewhere 2.4. And now if I try to close this notes, the tab got closed over here. Let's wait for a couple of seconds in order to ensure that memory cleanup happens. Basically, everything happened. If we try to see the JS heap, you see it got reduced a lot, right? Even if we try to go into the memory, we see it came back to 2.4 from where we started. So just adding a small thing, right, which is whenever we have this detached window and we are cleaning these references, it makes lot more sense basically. So whenever you are playing with the windows, make sure you're not just closing it, you are also cleaning up the memory. So are you going to take care of that? Put down in the comment. Let's talk about our eighth memory leak. Forget to stop listening. So especially there are two cases. Like one is stop listening when we talk about observables or event emitters, and the other part is like responding to any activity that is being expected. So which is in case of promises. So say suppose we have some promise, and what is the expectation? Either you will success or you will fail, right? Either of these two things should always happen basically in case of promise. What if you forget to do one of them, right? You forget to basically respond. There are scenarios where you will get those errors in your code itself, but there can be some glitches, some scenarios where you may not get any error in your code base because the intent is fulfilled, but you end up doing a memory leak. So let's see one of those example. So in this case, what we are doing, we are using promise.raise. Raise is something basically whichever gives us a response first, we are happy. So we have two kind of promises we are trying to settle over here. One promise is which is not going to settle. It does not respond with the success, or you can say resolve, reject or resolve basically. And the other one is it basically resolves, and but it does a lot of heavy computation inside this, right? It does some big computation. You don't have to worry about the computation, but it does some computation. So what if I try to execute this code? Let's see. If I go into the memory right now, if you see it is 1.7 MB some memory being used over here. If I try to execute this code where one is unsettled and second is basically responding, the unsettled probably may leak into some memory internally, and if you see this memory size is getting increased like by large extent, right? So such kind of glitches may probably happen because you are not consuming, you are not returning anything from these promises. So never ever do that. So try exploring more other such examples, and let's see in the second memory leak, the other memory leak. Let's talk about our ninth memory leak. So probably you may be knowing it, but let's discuss why this is important. What it meant by disconnect. Anything basically you started listening or you started observing, you have to ensure that you unobserve or you disconnect with that. So there are some observers which basically tries to do that. One is definitely the resize observer, right? You have this resize observer. Similarly, you have intersection observer and you have mutation observer, right? There are multiple observers. So what basically you have to do, let's see in this particular example. If you try to like resize, you see it actually scales. And if you disable this basically, and you can see this, there's a resize that basically happen. It doesn't scale. That is an implementation that is done using the resize observer. One thing which is very important, say suppose from here you navigate to some other page or you navigate to some other tab where you are unmounting this particular section altogether, right? In these cases, don't forget to call either the unobserve or a library function which is called disconnect over here, right? Either disconnect or unobserved is something which is very important. You should not forget, else you will leave a memory leak behind. Similarly, when you talk about intersection observer, you have the similar kind of method and APIs which helps you to either disconnect or basically unobserve, right? So similar kind of implementation you will get in the mutation observer. Whenever you have these observer, are always unobserved or basically disconnect. So let's talk about the last memory leak, 10th memory leak. So sometimes what we do when we have a large data, basically we want a infinite scroll type of functionality. So there are two type of memory leaks sometimes we do. One, we keep on appending those DOM element into the DOM itself. Say suppose this is a huge list, right? And there are thousands of item. In order to render those thousands of item or million of item, basically, you will have those items to be present and listed like this, right? Those will be n number of entries. You will see thousands of entries. Okay. People are smart enough sometimes, if you're already aware of the windowing logic or the virtualization of the list, how to create an infinite list using the virtualization and the windowing, which I have already talked in one of my previous session. So you may not be, you may be using some library so that you are ensuring you have a limited set of DOM basically element present in your main DOM tree, right? And you are just replacing that data and you are just manipulating with that 20-30 DOM elements or the list of items that you have. That is fair enough. But sometimes you forget to basically handle the same problem in your inner memory. When I say memory, inner memory, which is a browser internal memory. So sometimes if you are using Redux or sometimes you are maintaining the internal state, what you do, you keep hitting the API call, you keep getting the data and you keep appending that data inside your internal memory, either in form of Redux, either it is in form of your internal memory. You don't clean it up, right? Eventually you will see those, if those sizes or the data are heavy, or sometimes people have those binary data, or sometimes people have that base64 data for those images also in their responses, right? You will see eventually your memory size, your browser memory size is getting consumed a lot, right? So always look after those things. Nothing comes like free. Everything comes with a cost, right? So do look after the API calls that you are making. Do look after the data, how much data you are getting. Do look after what kind of DOM manipulation you are doing, how much DOM elements we have created, right? How much bulk operation basically you're doing. Are we doing those individual operation by n number of iteration, or we wanted to do a batch or the bulk call basically? So try out these things, and eventually I feel like you will find yourself in a better state when you are implementing those memory, or you're thinking about these memory leaks when you are implementing and when you are navigating in your existing code base. So we'll see if you are able to find it out any of these memory leaks. Please don't forget to comment down. I will be happy to see and like discuss more about any of these memory leak that you are struggling with. Wow, what a episode it was. So I had a lot of learning while recording this and hope you got something new to learn. So what you are waiting for? Go and try to implement it. Go and check out in your existing code if there is any memory leak. If yes, go and fix it. Go and discuss those memory leaks with your colleagues, with your seniors, and let's have some fun. And put down in the comment what did you learn new. So see you in the next episode. Keep watching Chakde System.